into the cloud. Okay, great. Thank you for reminding me of that. So it is currently being recorded, and that will be real useful. So this tablet they found, British Museum 13901, you do not need to have these numbers memorized or names, British Museum 13901. The final exam is a math test. The final exam is, solve this equation the way the Babylonians would have done it. Solve this equation the way the Egyptians would have done it. Numerical answers. There is no history on the final exam, even though I might mention the name of a tablet or something like that, but those aren't things that you have to know for the final. The final is so important because we're here to learn how to do math in the way that these ancient cultures did them. So the final exam basically is one question after another, very similar to the homework assignments. You should know that there's two groups of people in this class. There are people who are in the math education. They're taking this course for math education credit. But then there's also people who are taking this class as a math major class. And this class is geared towards the math teachers. So it's not as hard as it would be if it was a class just on its own for the math majors. Now, the math majors will sometimes get supplemental exercises and even lessons and videos to watch. But even with those, the math majors will find this course to be probably a little easy for them, just so you know. But there are going to be opportunities for the math majors to do some supplemental stuff. And honestly, if the math teachers want to do the supplemental stuff just for their own, they can. Somebody asked about the final. The final, you actually have to come in to school for the final. That's a very that's like a big requirement. And even for me to teach the course, that was a big requirement that I must be able to come into the room and take the final. I forget what day it is. I think it's on August 3rd, but it's like it might be August 2nd or 4th. It's like in early August. I believe it's either August 2nd is the final or August 2nd is the last day of class, and August 3rd is the final. I have to look that up. I will find that out for you. Okay.
Professor, real quick.
Someone asked in the comments about reposting. Yes, if you could send them to the Google Classroom. Just had a question: Is Blackboard a good thing that I just don't know how to use well? Does someone want to chime in on that? I'm just curious because I'm very bothered by what seems to be a very difficult, non-intuitive, not user-friendly thing.
Blackboard sucks.
It's bad. Okay, great. Thank you. I mean, as a teacher, it is, like I said, I mean, as I get older, I get worse at computers, but I'm pretty good in general. So Google Classroom is better. But I am sorry for the confusion. There are two classes. We tried to merge them into one. I just went to the Google Classroom. I hope that's going to be easier for everybody.
Just a real quick question, Professor. It says here in Google Classroom that the first two homeworks are due next Monday?
Yeah, because the math majors weren't even able to access Blackboard.
Okay.
So I just made it due for everybody next Monday just to give more people more time. I mean, the answers are already up there. So, but just I won't be checking it until after, but you could check your own answers that way. Okay, so as we can see on here, I have all this access Delta math code. I'll explain about that. This list of the lesson topics, you can kind of see where are we going with this. But today we have a lesson, and this is one of my favorite topics of all of them. So I'm pretty glad, and I definitely was not going to do it through video. So I have a question here for you to think about, and it's a quadratic equation. Well, find my. And the math teachers actually have seen this because I emailed them. There's a couple of dead spots on this iPad because the screen just cracked. My son dropped it, but I'll be getting that fixed soon. So I bought the $69 protection plan, thankfully. So here is a quadratic equation, very similar to what we see in an Algebra 1 class or pre-algebra. They even have this class, although it usually doesn't look just like this, but here's how it looks. And now I have a technology that's very important. I want to show you how to use it. So you come over here, and there's actually a link to this in classwork if you go to lesson 3, class 3, but you don't need the link, but there is a link to this. Where is it? Should be, let me see if I say view assignment. Do I see more stuff? No. That's okay. I'm going to type the link here, which says student.desmos.com. So if you go to that link, why does that not make a, it does not make a link, does it? You would think that, is that clickable? Okay. So that's a Zoom idiosyncrasy. HTTP student.desmos.com. So what happens when you go here, and why is this so important? Okay, when you get there, you'll see something like this. And we'll have this, I would hope, every single day. You don't have to sign into a Google account to do this, but it's asking for a code. So the code for today, which I'll type into the chat, is KPMSSH. And I'll type that in. That's the code. And you could say continue without signing in. It doesn't. Now, this is how I will measure class participation. And it will also be a way for you to be able to answer questions without typing it into the chat, because when it's in the chat, sometimes I don't want everyone to see an answer. I want to give everyone a chance to answer the question. So I have these, it's called Desmos Activity Builder. And those people who are math teachers, I hope that anyone who's a math teacher want to chime in the comment. Have you used Desmos Activity Builder? I don't know if you were a teacher during remote learning, but you missed a good opportunity if you didn't have this thing as one of your tools, because it's really great. So now what's neat is that on my end, I have a dashboard and I could see what everyone's typing. So the first, I mean what everyone's typing into this. So you have a thing here. It says, what are the different ways of solving this quadratic equation? And you can type into the box there and click submit. And then on my end, I can see what everyone's typing, so I can bring this up on my end. So if you're having trouble with the student.desmos.com, you can private message me your answer, and I'll see it that way. Okay, let me take a look on my end. This is such a good technology. You know, it's a free technology that you know, they will monetize one day with their own lessons and things. But I'll tell you, for something like this, it's really good. Now, let me just bring up my own dashboard and see. Summary. Here we go. Okay. So I see Marcus says completing the square quadratic formula, and Vanessa says completing the square factoring, possibly quadratic equation, using the calculator to find the roots. Algebraically, Grant says, set equals 0. Factoring, quadratic formula, graph, guess and check, algebraically, table of values. So this is good. And this is how I'm going to be measuring. When I said that class work is 10% of your grade, it means that there will be frequently stuff for you to type in as we're going along. And if you type stuff into all these boxes, you get a good grade in class participation. But if
Professor, could you
like,
see my response? Because I logged in under my City College email.
oh, who's asking that? John?
John Estorino.
Yeah, quadratic equations, and it says check different values. Yes.
Thank you.
So I can see everybody's answers there, and good. And yes, someone commented we're probably going to learn some Babylonian method today, and that's true. Let's take a look over here. So hold on. Yeah, I'm actually not going to go over any of the basic methods that you already know, like completing the square right now. I am going to come back to this question in a second, because part of it is related to a simpler question, which is a system of equations. System of equations, especially this one, is particularly easy because you can add the two equations together and get the y to cancel out. So systems of equations is, especially this one, Babylonians had a good feel for this system of equations. They also had a feel for another one. Imagine if instead of the two given equations being x plus y and x minus y, if it was x plus y over 2, that seems like a more complicated thing, and x minus y over 2. If those were the two given equations, if you add those together, and here someone could type into the chat, what happens to the left side when you add these two equations together? This is, when I say type into the chat, it's kind of like a call out and answer sort of thing.
But wouldn't it be 2x over 2 equals 7? So that's x equals 7?
That's right. So that's real nice. The 2x over 2 becomes x. And also nice about this, if instead of adding the two things together, if instead I were to subtract the two things, someone want to type into the chat or unmute themselves and say, what happens when you subtract x plus y over 2 minus x minus y over 2? That's right. I see that it ends up becoming 2y over 2, which is just y. So that's kind of useful. Now you're wondering, what about this? When is this going to come? That's not actually going to come for a while. We have to sort of build up to this equation actually. Okay. So an equation that, by the way, I will say something about this equation before I get into how to do it with their methods. So this equation, it's kind of amazing that this equation was around in 1600. That's a long time ago for them to be studying that sort of question. Math developed because it was practical, I needed a way to count my in Egypt, my bread and my beer a lot of the time. A lot of beer questions, actually, when we get to Egyptians. But they needed to count stuff, and they needed to be able to measure things for trading things. So to have an equation like this, x squared plus 8x equals 33, does that have any, did it have practical? Well, it was not phrased this way. It was phrased as a word problem. But the word problem wasn't particularly like illuminating. They would say the area of, oh, and by the way, this is minus just because that's just the question that's going to be my model question later. They would say the area of a square minus 8 times the side length. Is 33. And they want to know what's the side length, which is really something, because that's not a practical question at all. That's not a question that we need to be able to answer to do anything. When we use quadratic equations nowadays, we have like a projectile that's flying through the air and its equation is defined by a quadratic equation, or something with economics where when the price goes up, the quantity goes down by a certain amount and it turns into a quadratic equation. There's no way that anybody needed to know what the side length of a square would have to be if the area of that square minus 8 times the side length was 33. So what this shows is that the Babylonians were, even back then, doing like math for math's sake, pretty abstract. This is not a question that has practical purposes. Eventually, later on in life, there were times where quadratic equations were important for scientific reasons. But in Babylonian times, there was no reason to really care about what the answer to this question was. So it showed that math was developed way before this. If by this year they're already doing totally abstract math, x squared minus 8x, and just wondering, how far can I go? Of course, I could solve linear equations pretty easily, but like, can I solve questions of this sort? And they were already doing that back in this time, and they had a really ingenious way of doing it. But again, I'm building up to that question, so it's suspenseful. Before we look at that question, I have another question. And a lot of times they worded these questions this way: a system of equations. We saw one system of equations already: x plus y equals something, x minus y. But here is a system of equations. Here is one. They would write it in words. They would say the sum of two numbers is 14, and the product. So given sum and product. So I'll write down given sum and product. By the way, let me take a quick look over here. Let me see what question 2 says here. Okay, we're not up to that question yet, but that will that we're going to do question 2 after I go over this. So this is, by the way, just out of curiosity, because the way my screen is, can you see? Thumbs up. Can you see? I just wrote hi on the very, very bottom of the screen, or do you only see the portion that I can see on my web browser?
Only the portion that you can see.
Okay, thanks. So let's correct that. Let me change my window size. So I don't know, so some of you are math teachers already or training to be math teachers, but if you were teaching during Zoom during the remote year, 2020, hold on a sec, I'm working on getting this. I had like 5 screens simultaneously back in those days because I'm a high school teacher as my day job. But currently I'm trying to do it with just 1 screen, and I realized 5 screens was really, well, a lot of people thought it was overkill. They thought I was showing off with 5 screens, but it really helped. Anyone in the chat want to type in how many screens did you have going on simultaneously when you were doing Zoom teaching? 2 laptops. Okay, well, better than 1 for sure. Okay, now can you see my hi on the very bottom? Thumbs up if you can. Okay, and Grant, you have a big, since you're right underneath my face, I'll always be looking at you. Oh, I see John also. Yeah, I need to dig up some screens. Okay. Now, in modern ways, we could obviously solve this through just guess and check. 10 plus 4, 10 times 4, right? But maybe it's not always so easy, you know? So yes, I'm doing an example that we don't need an algorithm for, but we're going to learn an algorithm that will enable us to solve, you know, this question and other questions that might be a lot harder than this one. Now, if you teach algebra, they would say on the regions, you know, algebraic solution only. They would not want someone to, as so-called, guess and check. But yes, the answer is 10 and 4. But if you try to do an algebraic solution, imagine this was the regions, and someone said algebraic solution only. Does someone want to maybe unmute or let me see, can I unmute and describe? Let me see if, I really miss all my screens because I'd be able to see hands up. Let me see something. Participants. Instead of, I have like 20 windows up on one screen is what's going on here. And it's not as convenient. Let's see, hold on. Where are all the names? Participants. There you are. Okay, someone want to raise a hand to explain what do we mean when we say algebraic solution for this one? I'll look for a hand on my participants list. No one, no hand?
Yeah. Yes, to
There we go,
solve.
I see one. Okay, so Beth, what would that mean, algebraic solution? If they demanded an algebraic solution for this question, what would that look like?
So for the second one, I would solve it for one or the other of the variables and then plug it into the first one and then turn it into a quadratic by multiplying by that variable.
Okay, so that's great, thank you. So let's say I said y equals 14 minus x. And then I turn it into this. This is a substitution method. Move everything over to one side. And now what? I'll go for another hand. So you could click on the hands icon and I'll call them. Now that it's been turned into a 1 variable quadratic, I see, do I say axis?
Oh, actually, my name is Crystal. Axel is, I was doing remote with my kids as well with math. So
Okay, Priscilla then?
it's Crystal, yeah.
Okay, so how do we complete this question now?
Like how detailed do you want it? I mean, I would just solve for X by doing FOIL.
Mm-hmm. So factoring, yes.
Factoring, sorry, factoring is the other way.
Yes,
Opposite of FOIL.
that's right. So, so what does it factor to, just so?
It should be, so the middle should equal minus 14. So it should be 4 and 10.
That's right. Now, I want you to notice something. If somebody took this original question and we said algebraic solution only. And they looked at it and said, okay, I'm looking for two numbers that add up to 14 and whose product is 40, and said, oh, it's 4 and 10. That person, right, would get no credit. They didn't do an algebraic solution. Yet, Priscilla, in this way, factors. But look what happened. In factoring, in finding the two factors, you had to think to yourself the exact same question. What two numbers multiply to give me 40 and add to give me 14? So it's just kind of funny that person who just starts here and says, I need two numbers that add to 14 and multiply to give me 40. That person gets no credit for coming up with 4 and 10. Yet this person who turns it into a quadratic equation and factors the quadratic equation by asking themselves, what two numbers add up to 14 and multiply to give me 40, that person gets full credit. It's just kind of funny about that. Factoring, if this was the original question, there'd be no reason to turn it into a quadratic equation and to factor it. Now it might not factor, and then the quadratic equation might be useful, but since the Babylonians didn't have irrational numbers, their things would factor if we were to do them this way. Anyway, I just find that kind of funny that this question, which is a classic Algebra 1 question, is not much different from the quadratic equation, factoring it. It's still, you can't avoid, I need to find two numbers whose sum is 14 and whose product is 40. Well, the Babylonians would do this question a different way. So here's our first Babylonians thing for today. And they wouldn't use variables. They would just say, they could say in words, the sum is 14 and the product is 40. Or they could say there's some sort of rectangle that has an area of 40 and a perimeter of 28. And they say, I want to know the dimensions of that rectangle. That sounds a little more practical, finding dimensions of a rectangle that has area 40 and perimeter 28. But it's not that useful of a question in that it's more like a riddle, than anything else. I mean, someone might invent some kind of use, but no, this is not, even if I make a rectangle, this is a question about a rectangle, it's still a recreational math question. It's not a practical math question. So big thing for today is that the Babylonians were doing sort of recreational math. It was already past the point of practicality, which is really, I was surprised when I realized, when I learned this. So we found these tablets. Babylonians put everything on these clay tablets, so they survived for thousands of years. Other cultures, use papyrus. Egyptians around the same time, most of those papyrus, disintegrated. So we have a lot of Babylonian stuff. Oh, other windows supposed to be showing? Do you mean someone asked about other window? There's only one window. I mean, maybe you could see my face in a little window, and you can see the iPad in the other one, I hope. Okay, so the Babylonians solved this question by doing some calculations. And I'm going to first just show you a sequence of 6 numbers. And I just want you to ponder where these numbers might have come from. Although in the Babylonian tablet, they actually sort of explained how they got these 6 numbers. But the last 2 numbers are going to be the answers for X and Y. Okay, here they are. The first number is 7. The next number is 49. The next number is 9. The next number is 3. The next number is 10. And these last 2 numbers are the values of x and y. It doesn't matter which one's x, which one's y. So these 6 numbers, the progression, these 6 numbers is showing you the process of an algorithm. And I'm going to put you into groups now for a few minutes. I want you to try to ponder what are these 6 numbers? What did I, for sure they're using the 14 and 40. If those are 2 different numbers, these 6 numbers would be 6 different numbers. So what do you think their algorithm was that led them through this sequence of 6 numbers? 7, 49, 9, 3, 10, 4. And then maybe how is that sequence of their algorithm, whatever their algorithm. So I want you to try to figure out the algorithm. But if you do figure out what the algorithm was, what the sequence was, what they did to get these numbers, can you try to ponder, why does it work? So for this, let's see if I can do it more. Now the group, hold on a second. I haven't done, breakout rooms, of course. Okay, I'm just going to we have a lot of people, 25 people. So let me make 6 breakout rooms. Eventually, I might split up the math teachers and the math majors, so they're in breakout rooms with each other. I don't want the math majors to necessarily give away the answer too quick. And but for now, I'm putting you into 6 rooms, and I'm going to pop into the different rooms. I know, because I've been in breakout rooms before. There is a lack of energy. Something about a breakout room makes people become very lethargic and even lazy. Even people that aren't lethargic or lazy. I don't know what it is. A breakout room, there's just something inherent about it that makes people just not want to talk to each other, not want to share. I don't know what it is. Because I've been in a breakout room and I felt lazy in it and not, just unmotivated to do it. But I want you to do your best. I'm going to give you about 10 minutes to ponder this. So I'm going to pop into the different rooms. I want to see people. I understand some people have families at home and they may not be able to have their screen on and their mic on at all times, and that's, I understand that. But do your best. So let's give you 10 minutes now to ponder what is their algorithm and why does that algorithm work? Can we?
And the algorithm is to solve x plus y equals 14 and xy equals 40. Is that what
Solving this question? Yeah. This sequence of 6 numbers somehow led us to the x and y value. Okay. Now for today, I don't have us separated by because of the way the Zoom works. I couldn't pre-assign the rooms. So meet your neighbors, introduce yourself, and start talking about this. Give you 10 minutes starting now. Oh, that's interesting. Assign automatically. Oh, wow, it already made the group. Okay. So I'm going to open the rooms now. Okay, everybody, welcome back. First thing I want to say is that maybe that pep talk speech about doing good in the breakout rooms worked, or maybe it would have, maybe you didn't need that speech, because what I saw in visiting each room twice was exactly the kind of participation that will get people full score on the participation grade. That was exactly what I was looking for. Really, really good. That's a good way to start our first breakout room, because people were really talking. Now, it's a really good question, which helps. If you put people into a breakout room with a really bad question, they're less likely to have a good discussion. But this is a really, really good one. Now, so a lot of people figured out that the 7 must have somehow come from 14 divided by 2. Because we have to use the 14 and the 40. Now in the Babylonian tablet, it said take half of 14, and then it said put 7. So they explained what the algorithm was, but they didn't explain, why the algorithm works. So that's what we're going to analyze. The 49 came from squaring the answer that just happened. And they actually said it in the tablet. It said square 7, or it said 7 times, whatever it said. Now the 9 is a little bit confusing. So let's go for a volunteer. Let me find, someone want to type it into the chat? Wow, I really need screens. I have, where?
Is it possibly 49 minus 9
Yeah.
40?
It is. It's the answer that just happened, the 49, minus used for the first and only time, the 40. It needs to get used. If it was a different number besides 40, it would be a different answer. And the 3 is the square root of 9. Now, just from looking at one example, you could have interpreted it other ways, but when you see multiple examples, that 3 is the square root of 9. You might have said maybe it's just the previous thing divided by 3. With one example, that would be pretty reasonable also. And then the 10 is the 7 plus the 3, and the 4 is the 7 minus the 3. So before we analyze this algorithm and why it works, because on a test, on the final, I could see myself giving a question like this and just saying, can you write down, the 7 numbers that the Babylonians would come up with as their like partial results. So their algorithm, again, it's not explained yet, but their algorithm is divide the sum by 2, square that answer, subtract from that answer the product, take the square root of that product of that difference, and then add together the 7 and the 3 to get 10, and subtract to get 4.
Professor, can
So
you?
what I would like you to do now, just to see if you can apply this algorithm to another example, would you go over, if you have it, to the Desmos activity, and page 2 asks you to fill in the 6 numbers. Again, we haven't analyzed it, so it may seem like magic right now, but go ahead and fill in the 6 numbers for this similar question that just has different numbers, different sum, and different product. Now, so on my screen here, I'm looking over people's answers.
I'm sorry, there's no submit button on this question, right?
Right, there's an, yeah, it just comes up on, even without submit. As soon as you type something into a cell, it pops up on my screen.
All right, cool.
Can you show the two equations again, please?
Oh, are they not up on the screen?
Not on mine.
Huh.
I have your original problem, the prior problem up.
And on the right, just to the, you see the yellow, the, do you see the highlighting?
Yeah, I see you're highlighting, but I want to see the actual two new equations.
Oh,
Go to
Scott,
Desmos.
Oh, there they.
okay.
Page 2.
I see it.
Oh, I got you. Yes, I got you. Yes, you click on this next to go to page 2. And I also have the equation here on the iPad written in small, highlighted by blue there.
I see it. now.
Highlighted.
Thank you, Professor.
Did the Babylonians have negatives? I'm just curious.
No negatives.
7 and 5.
They had, as you saw, pretty nice complicated decimals.
And how would they do this if the number was not even? So 13 divided by 2 is like 6.
Oh, well, they were pretty good with their decimals. So there's a lot that have fractional answers, but there aren't any with, like, with irrational. There's no irrational answers, but yeah, there are questions with fractional answers. Okay, so let's take a look. We take half of the 12, we square it, we subtract from that the 35, we take the square root of that. 6 plus 1 is 7, 6 minus 1 is 5, and 7 and 5 are the two answers. And I will do this. This would be a perfect question on the final exam. Absolutely perfect question, because only someone who knows this algorithm would have any chance to get it right. If I said, show me the 6 numbers the Babylonians would do to answer this question.
Can you repeat after 36? You kind of cut out there for me.
I did, so after the 36, I took the 36 and subtracted the product, the 35 that hadn't been used yet.
Okay.
And then I took the square root of 1, which was still 1. And 6 plus 1 is 6 minus 1. Now, a big part of the class is analyzing these algorithms. So I don't want you to think just because on the final, I'm not having us analyze algorithms. It could be on a homework question, analyzing an algorithm, doing your best. But on the final, I don't think there's analyzing the algorithm. Why does this algorithm work? But it's more about knowing the algorithm. But in class and on homework, and just why this algorithm works is the goal of today's lesson, really. And then I have a couple more applications of it. One thing, when they first found this tablet, they had a incorrect analysis of it, which I always find kind of funny to look at, because it shows how when you interpret tablets without any explanation of why the algorithm works, you can get multiple interpretations. And
Sorry, what is the first? Is A? X plus Y equal by A?
oh, I put a letter there.
Okay.
I just called it B and C.
B and C. Thank you.
Yeah. Now, this analysis is not considered the Babylonian thinking, and we're gonna get to the Babylonian thinking. The Babylonian thinking is a lot simpler than what I'm going to show you right now. But I show it to you because no one really knows. But I think you'll be very convinced that the simpler explanation is much more likely to be how the Babylonians thought of this. But check this out. If you actually did this process with B and C instead, look at what happened. Your first number would be B over 2, which would then turn into B squared over 4 when you squared it, which would then turn into B squared over 4 minus C, which would then turn into square root of b squared over 4 minus c. And the two answers then would be b over 2 plus the square root of b squared over 4 minus c, and b over 2 minus the square root of b squared over 4 minus c. And in the chat, if you did it that way and said, oh, wow, I just noted, what does it appear that they invented?
What did you say, Professor?
The
What it looks-
quadratic form.
It looks like,
The quadratic formula.
yes, that's right. This really resembles doing this 6-step algorithm with B and C instead of numbers. We get two answers that resemble, if I go like this, B over 2 plus, if I change this to B over 2 squared minus C, I could do some other things, like I can multiply. If I put a 4 on the inside and put an over 2 on the outside, it keeps the value the same. And it starts to look, it looks like quadratic formula. But this is not actually the best analysis of their algorithm, and it doesn't give an insight into their thought process. But there was a time where when they first found it, said, oh, wow, look at this. I ran it through, and it ended up with something that resembles the quadratic formula. Okay, now for the big reveal. Let's go back to the first question. I think it was x plus y equals 14. xy equals 40. So yes, the 7 was x plus y over 2. So now what I'm doing is
Yes, the first one, yes.
there we go. I'm taking the x's and y's and seeing what's going on with those. Now the 49 was x plus y over 2 squared. And here is the big insight, the 9. In terms of x's and y's, it's x plus y over 2 squared minus xy. Which, if I leave it like this, and I do the next step, which was to take the square root of both sides, I actually lose the insight. So let me erase this. The key thing is this. You see, in yesterday's lesson, or lesson number 2, I mentioned that one thing the Babylonians really knew well was that there was a relationship between x plus y squared versus x minus y squared. That relationship was, I like to write it this way, x plus y squared minus, because x plus y squared is x squared plus 2xy plus y squared, and x minus y squared is x squared minus 2xy.
Yes,
Plus-
it's the same formula, yes.
It's like the same formula. The only
but
difference
they
is
have one minus, yes.
one's plus and one's minus.
Yeah.
So we could say this, the x plus y squared, to turn this plus into a minus without magic is subtracting 4xy. And that's the relationship. And tell me, in one of the videos, did I'm not sure. I hope the video had it. Did it have a cool like geometric picture like this? Hold on.
Yeah, like the floor tile.
The floor
Yeah.
tile, yes. This is a pretty cool picture for showing if this is like y and that's x. The and so the big square is x plus y squared, and each of the rectangles is 4x is xy, and when we subtract, the thing in the middle is x minus y squared. So with the floor tiles, the Babylonians, this is the one fact that they really knew, that they figured out, because they use it for everything. You know, there's an expression, if all you have is a hammer, everything looks like a nail. This relationship, x plus y squared is similar to x minus y squared, differs by 4xy. It came up in lesson 2 in their multiplication algorithms that involve the table of squares. And this process is going to be because of this. Because if I take this formula and I divide everything by 4, it turns into, let me just write, over 4, over 4, over 4. If that over 4 is not inside the parentheses, if I want it to be inside the parentheses, I have to make it over 2. And I get an identity, which is this, x plus y over 2 squared minus xy, no 4, is equal to x minus y. That's basically the same identity as this one. I'll use a different color. That identity, that's that identity with everything divided by 4. So what this means, when I come back here, see this x plus y over 2 squared minus xy? Yes, that's a complicated thing, but it can be replaced with
X minus y over 2 squared.
That's right. And if I do that, then when I take the square root of both sides, I end up at x minus y over 2. So look at how much nicer x minus y over 2 is compared to if I left this thing as it was and took the square root of it. That would give you no insight. So they started with x plus y over 2, and through this clever series, squaring it, subtracting, and square rooting it, I weaved my way to get x minus y over 2. And remember from before, where is it? Pulled up a lot of pages here. It must have been.
Is the first one, I think, that we have x plus 1 over 2.
Oh, there it is.
Yes.
There were more pages. Here we go. Remember this? If you know x plus y over 2 and x minus y over 2, add them together and you get x, subtract them and you get y. So this last step, when you do the 7 plus the 3 to get 10, that's x, because it's x plus y over 2 plus x minus y over 2. And the y, which is the difference between those, is 4, because that's x plus y over 2 minus x minus y over 2. So that, again, the quadratic formula interpretation is sort of, if that was their reasoning, they'd be very far ahead mathematically. But that doesn't take anything away from this interpretation, which I am extremely sure is the proper interpretation, is very clever, and it doesn't involve the quadratic formula, and that's even better, to avoid the quadratic formula. So that's what's going on. That's why their algorithm works. They somehow managed to get x plus y over 2 and convert it into x minus y over 2 through a series of squaring and subtracting.
Okay, I have a question for you.
Yes.
Do you think for those of us trying to be math teachers that this is a better way to teach this than a quadratic formula? Or substitution or any of those?
No, I wouldn't. I don't think that would be a good way. There are, this question, what's the sum and what's the product? There are some clever, like, I would never teach it this way, because it relies on this identity, which is very difficult to get to. Later on, we're going to learn that in the 1500s, so 3,000 years later, what was the question? 14 and xy equals 40. Cardano, who is someone we'll study at length near the end of the course, he did a real clever thing where he said, if two numbers add up to 14, either they're both 7, or one of them is like, if one of them is bigger than 7 by some little amount, the other one is smaller than 7 by the same amount. And then you can substitute 7 minus a for x and 7 plus a for x and 7 minus a for y. And you get 49, difference of perfect squares. You get 49 minus a squared equals 40, which gets me that a squared equals 9, or a equals 3, which makes x 7 plus 3. I like that way of doing that. Like that didn't.
That's cool.
Yeah, it didn't require an identity. So this question, find two numbers whose sum is this, whose product is this, has been revisited over the centuries. I love this. Since you asked, I just fast forwarded to Cardano for a second because that. So if on the final I said, how would Cardano answer this question? But this is going to get revisited when we do Cardano. We'd have to do it that way. But no, I wouldn't show this method for algebra students. But it is real clever for us. Now,
Professor, I have a question.
Yes.
Now at the answer, we can put 10, 4, and 4, 10 on the same time, or we can put only one pair of numbers, because we know on the math it's different, 10, 4, and 4, 10.
Yeah, if it was x plus y, it wouldn't matter. But we're going to look at the next question, which is similar to this, but it's slightly different. And this slight change is going to require us to modify the algorithm, because now instead of the sum, I finally made it to the warm-up question. 14 out of 24 people are teachers, so I've been teaching in high school for almost 30 years. And I do like to have like the warm-up question, and then you sort of go back to an easier thing, and then you build up until you reach the warm-up question again in different contexts. Okay, there has been one modification. That's a minus sign now. How would you have to change the algorithm to work to answer this question? Now I'm putting you back into breakout rooms. And I believe, let me just check out, do I have, if you go to, as you're in the breakout room, you can go to page 3. Let's see, I hope it's page 3. Yes. How would you adapt the Babylonian algorithm? Oh, you're not looking at that. That's my page. If you go to page 3 on the, oh, you are looking at it, yes. So I'm going to put you back into breakout rooms for this question. You're going to have to, the same algorithm is not going to work, but how are you going to do? I'm putting you back into the same room, so I like to see the same level of discussion, but this time not just how the algorithm change, but why does it work? Did I write that here also? I even said, how would you adapt it? If you could put into this box also, like, why does that new method work? So try to come up with a new algorithm. This is a great question. I'd like to give you 10 minutes again. So have a discussion about this, and here you are into your rooms. Okay, everybody, welcome back. Okay, again, I liked what I saw in the different breakout rooms, and I actually saw some alternate ways, all based on the same idea. The algorithm is the one that the Babylonians would do, would be to first divide 8 by 2, sorry, just like before, and square it. But the difference is now, instead of doing 16 minus 33, instead I do 16 plus 33. So that's the only difference in the algorithm. In step 3, there's a plus instead of a minus. Square root of 49 is 7. And when we do 7 plus 4 and 7 minus 4, we do have to be careful that in this case, the x has to be the bigger one. So 11 has to be x, whereas before it didn't matter which one was x or y. So that's the algorithm. One difference. And it's based on, it's based on this identity again, but this time, sorry, there's some weird rectangles appearing. This time it's based on the fact that x minus y squared plus 4xy is equal to x plus y squared. So whereas the 8 over 2 was x minus y over 2, 4, eventually this 7.
Professor, do you have some rectangle sitting on top of your work? I can't see what you're doing.
Oh, so these rectangles, they are very annoying.
And I got a square in here. I mean,
Let me see how to get rid of this rectangle. So you see, I grayed out the bottom here. Those rectangles weren't supposed to be able to even happen. But now at least they're not obscure. They're not covering the stuff anymore. So
can you please go back a couple of steps, because I couldn't see what you're doing while you were talking, please.
Okay. So like the previous example, where in the previous example, we went from x plus y over 2 and somehow ended up at x minus y over 2 by subtracting the 33. In this one, we go from x minus y over 2, and I'll write in what's going on here. This is x minus y over 2 squared. And the big step, which I'm going to circle here, and I'm going to put an arrow here. It looks real ugly. It looks like x minus y over 2 squared plus xy. But we can replace that with just x plus y over 2 squared. Because, again, the hammer that the Babylonians had was this identity. It's really slick. It's really clever. And this question, there's only, x plus y equals and sum and product or difference in products. And then there's going to be applications of these. Oh, I see some people might have went into the chat. Hold on. Oh, I see. Mm-hmm. Okay. Yeah. This definitely ask questions if you feel that I'm going, too quickly. Because the truth is, even if I ran out of time on the lesson, I would just say watch the rest of some video to whatever I didn't cover. So I'm not in a huge, hurry, because I have this opportunity to run out of time and say, okay, just watch the last 15 minutes, on a video. So,
Professor, in that vein, can you take what you just did here and fill in that graphic organizer so we'd have the steps organized, please? The one that you showed in Desmos, please.
Oh, you mean the 6 numbers? Because the Desmos are you talking about this step 1, 2, 3, 4, 5, 6? Because
yeah.
I think you're talking about this. I mean, this isn't a graphic organizer. I just needed a place for you to put the 6 numbers in you know, rather than just type it into a big text box. So this isn't really anything profound here. This is just, I needed some way for you to put the 6 numbers into 6 boxes. This isn't any sort of, it just says step 1, 2, 3, 4, 5, 6.
Right,
So,
but aren't they the same steps that you're employing to solve this problem?
well, except step 3 was slightly different, because step 3, I added the 33, whereas in there's just one difference. Yeah, I added the 33. So step 3 is slightly different. There's a plus here, which in the other one, there was a minus there. And that was because we rearranged this identity. So, you know, it was x minus y squared. You have to add to x minus y squared, right? X plus y squared is bigger than x minus y squared. How much bigger? Well, you'd have to add 4xy.
But I think you've gone so fast, I couldn't even see the difference between the add versus this one and the subtract and the other one. I'm trying to keep up with you. It's really fast and it's all over the sheet here.
Oh, well, I see it as a purely straight line from a question that had a plus here, analyzed it, and then we modified the question, you know, a slight bit by changing the plus to a minus, and then interpreted. But even if you weren't in the breakout room able to figure it out, and honestly, on the final, you wouldn't have to analyze this, why it works. It helps to know why it works, you know, as far as like, you know, remembering the steps. But this plus here, and maybe I should go just write to write down on its own page. I'm going to write this down. This one works because x minus y squared, without the over 2, plus 4xy equals x plus y squared. You can see that just by foiling both sides and seeing that one has a minus 2xy, the other one has a plus 2xy. But if I divide everything by 4, this turns into x minus y over 2 squared plus regular xy equals x plus y over 2 squared.
It's 11 o'clock.
Thanks.
Sorry about that.
Here's the 33. This was the 16. And this was the 49. So, see, I think you're asking a very good question. I think that this, I hope, this sort of step kind of showing the identity, that's an identity that, you know, Algebra 1 student can verify, you know, with, can verify with just foiling. It's not so obvious, this step here, that dividing everything by 4 would turn this identity into this other one. But if you look at this thing here, that is the same thing as what I wrote right here. So I was able to replace the x minus y over 2 squared plus xy with just x plus y squared, x plus y over 2 squared.
Sorry, Professor,
That's
will
very
we need
complicated.
will we need to explain it like this, or could we just do the steps like I put on the chat?
Well, on the final exam,
Right.
it would be the steps.
Okay.
But there might be other questions that are not these exact 2 questions, you know, that we want to, you know, go even, you know, go more with. So understanding the algorithm isn't going to be what's important for the final, you know, which is 40% of the grade, but it might be important for homework assignments. It's important for you to be able to you know, be thinking about, you know, why the things work. But even on a homework assignment, I might ask a question like, how would this question change if this happened? And you would just try your best. You know, homework is, you know, did you put in an effort for it? But so the answer to your question is you could probably get by without understanding this one fully, you know, just say, okay, I'm just going to remember for this one, you know, it's plus. But I will say that the algebra involved in following this one is throughout the course. This is one of the easier ones, so as the course goes on over the next, there's 14 or 13 more classes. If you're struggling with like this identity, you definitely want to brush up on your, on your algebra identities and the FOILs and things like that. Because it will make some of these, you don't want to go through the whole course like just memorizing this algorithm and not having a feel for why it works. So I encourage you to, you might have to stare at this thing for, an hour at home, which is, totally, in a summer course where you get a whole semester, you think of all the hours that a semester involves, and here they compress it into 16 days. So yeah, you might find yourself having to stare at this, for an hour. And some people maybe see it right away, but this is the kind of level of analysis that definitely I'm going to encourage you to do, but you could get by without it, at least, for the final exam and for the homework, but you wouldn't enjoy the course that much because it would just be kind of, you would, this is the cool part, the algorithm, yes, it's like magic, why does it work? But then when you see the trick, oh, I see, that's why it works. It's real important for that. So I know I gave a sort of half answer there. I do highly encourage you to stare at this one and to talk to people in the class, and I'll also stay after class and try to help you out if you're not seeing, this relationship. Okay. Now, I encourage people to ask questions because for every person, I used to say this in teaching high school, you're not the only person who has that question probably. So you should ask a question. And in fact, I saw someone say, "You're welcome, John." Was that for asking a question or, okay.
Christina, I put the procedure on the chat, so I thanked her for that.
Yes, and for sure, I want people to, on the Google Classroom, there's actually a way to for people to leave comments, and chat to each other. So I encourage that. But yeah, okay, so now we continue. So at this point, we've seen there's these two questions, x plus y equals, x minus y equals. But there's three other questions that we need to look at. And we are finally back. We actually hadn't gotten back to it yet. We're actually back to it just now. We haven't seen it since the very first thing in class. I don't know why I made a whole big deal that I cycled back to something, because I'm cycling back to it for the first time right now. This question. I'll have to watch the video to see I was making a whole big deal about how I like to cycle back, but I'm cycling back right now. I didn't cycle back. Remember this question? This was the warm-up question. And I asked, how many ways are there to do this question? Now, people say quadratic formula. There's something called completing the square. There's moving the 33 over to one side. Moving the 33 over to one side and factoring, or using the quadratic formula. But if you teach algebra and a student did this as their first step, you would crumple up their paper and give them a 0. And what is that? Someone type into the comment, there's some 14 people in the class are teachers who maybe teach algebra. And what's a tempting thing to do as the first step that makes teachers so upset? And we'll see that maybe you're not justified in being so upset. What is it? You can type it into the chat. Someone even wrote it as a possibility. No one had. Let me see if there's someone. Okay, when you say, Beth, the student is trying to factor, what do you mean by that? Because I didn't see anyone say what would that look like?
Well, I think they're making this common mistake where they're trying to use one of the methods where you have to set the equation equal to 0 by subtracting 33, and they haven't done that.
But what would they have done? What would that look like as their step? Because there's no step. Oh, I see.
Oh, yeah, they could
You're
factor
saying,
less.
you're saying they had x squared minus 8x minus 33 equals 0, and they added the 33 to both sides. What if they started with this question? I see from Vanessa and Sonelia. X times x minus 8 equals 33. If you're an algebra teacher and a student did this, you'd be very upset. Yet, this is going to be our first step for the Babylonian method for solving this equation. X squared minus 8x equals 33. Check this out. This is resembling, it's a product. It's two things that have a product that equals 33. I'm going to on the side, I'm going to replace this x minus 8 just to give you like a, I'm going to just introduce, as they say. Where did my question go? There. I'm going to introduce a new variable. I'm going to write replace x minus 8 with variable y. So now the equation turns into xy is 33, which is half the type of equation that we've been doing, given sum and product, or given difference in product. Anyone know what I'm going to put underneath the xy equals 33?
X minus y equals 8.
That's right. Because if this is x and this is x minus 8, they differ by 8. X is 8 more than x minus 8. X minus 8 is 8 less than x. So the difference between x minus y is going to be whatever that number is. And now we run it through the 6-number process, which I hope you're getting good at. 8 divided by 2 is 4. 4 squared is 16. 16 plus 33 is 49. Square root of 49 is 7. 7 plus 4 is 11. 7 minus 4 is 3. We got to be a little bit careful here. The x is the bigger one because x minus 8 is the smaller. So this is x, and this is x minus 8. In other words, the answer to this question, I know there's two answers, but the Babylonians wouldn't think of it that way. They would just say 11. And 11 is the answer to that question. So they very cleverly turned this question into this question. It's very sneaky. And they utilized the forbidden math step that every Algebra 1 teacher yells at their students for thinking of doing.
But why would they ask the first question?
Do you mean the first, this one?
Yeah.
I mentioned in the beginning.
Did mention a little bit. I remember. Yeah.
They said the side of the area of the square minus 8 times the side length equals 33. What's the side of the square?
Right.
No, there's no reason. It was not. They were already beyond practical applications. I mean, they also did plenty of practical applications, but this question.
This is like math for fun.
For fun, you know, they were like, I think religious figures that were like the people who did the math, you know, and they did math research basically, you know? Pretty amazing. Now, let me see if I have a practice question like this. Let me just see what is this saying?
Professor, I have a question.
Yes.
How old is the technique completing the square? Because when you said that, like, I don't know, when I taught algebra 1 and a student did that, I didn't get upset. I just, anytime a student tailors off from what I'm doing, what textbook, I never like get angry. I'm like, I'm just curious. Why'd you think that? So when I saw that, and when I was in groups, I kept thinking, especially the last group that we were in the last session, I was wondering, and I was wrong, did the Babylonians were trying to, well, they didn't know what they were doing at the time, but were they trying to do something like completing the square and like, we're like, got to a point where like, never mind, let's go back to what we were doing. Because
very good question.
Because every time I read the crest of the peacock now, and I think about like where everyone around the world was thinking, I just want to know how old, I didn't get to that part in the book, but how old is completing a square? Just a side question.
So are you in the math teacher group or the math major
I'm
group?
the math teacher group. I'm part of the math teacher group.
Oh, so if you, in the Google Classroom, because the math majors have additional, have a supplemental assignment, which has them watch a couple of more videos with more, types. And one of the types is, here, let me just go over here for a second. So math majors, it says supplemental for math majors, class number 3. They have extra homework and extra videos to watch. And one of them is that they did have, the Babylonians sometimes did these questions with a completing the square type thing. Except the only square they knew how to complete was x squared plus, was x squared plus 2x plus 1. They only knew how to complete x squared plus 2x and to stick a plus 1 at the end of that. So they had to get really clever when there wasn't x squared plus 2x. So you can watch, if you go to supplemental, you can watch a video about how they did, they had a completing the square type thing also. A different, totally different algorithm.
Thank you.
But for the math teachers and the pace I'm going, I'm not teaching that one except through these supplemental videos. So let me take a look at what I have here. No, I don't think I think I want to go. Okay. I have a question for you to do in groups right now. I want you to take that question we just did. And how would you change the process if there was a plus instead of a minus? So here I have x squared. So we just did, oops, I'm showing you the wrong page. Here's what we just did. What I showed you is that if you ever have a question like this, x squared minus something x, you factor out the x, and you recognize that this is very similar to xy equals 33. But if this is y, it's smaller than x by 8, so x minus y equals 8. We should probably practice one of these first. So I think I'm going to have everybody, I didn't have this in it, but I'm realizing that I'd like to throw in.
Thank you.
This question, sure thing. So let's say x squared minus 10x equals, let's say 24. And I'm going to put you into groups. For this one, I'm only going to give you like 6 minutes in the groups. Let's master this type, because we've learned 3 types of questions so far. X plus y, xy given, x minus y, and xy given. This is the 3rd type. but there's five types today. So this is the third type. I want to practice it before going to type number 4. So everybody can go into their groups and talk about doing this question. It's got the minus just like the other one did. So I'll give you 6 minutes to talk to each other about type 3. Again, 5 types. This is type 3. Okay, so here I have the solution. And as you can see, we factored x times x minus 10. You know, I mean, I like to change the x minus 10 into a y. I like to. I think it makes it easier to follow. I could imagine somebody not doing that and just calling it like x times x minus 10. I think this is a nice substitution so that we can, as they say in math, reduce our original problem into one that's more familiar to us. One of the groups.
I have a question.
Yes.
Sort in, how do you know if you're going to use the 24 or the 10? Because I thought.
Did you mean when you got the 5 here?
Yeah.
Well, in this, the 5 is the 5 is x minus y over 2. So whether or not they write which equation is on top doesn't matter. The equation that's in all the other ones, I wrote the x minus y equals 10 and xy equals 24. So maybe you had the feeling that it's whatever equation is first, you know, that you use that number, but you always use the number that's with the x minus y or the x plus y first. Whether it doesn't matter what order these two equations are written in, whether it's x minus y equals 10 and then underneath it xy equals 24, or whether it's xy equals 24, we always want to have this one. This is the thing we divide by 2. And the reason why is because we weave our way from xy minus over 2 to eventually x plus y over 2. Whereas if I started by dividing the 24 by 2, that would get me xy over 2. I can't really, we don't have an identity that involves that. So I'm glad that you asked that question, because sometimes I might put the xy equation, you know, first, and I don't want people to think it's just whatever equation's first.
Oh, okay.
So yes?
I should be using the algorithm, but one could say that, one could say that it's always the addition or subtraction one.
Yeah, well, this turned into this one turned into the subtraction kind. It turned into type. So type 1, if I were to like elucidate what we've done so far, type 1 was the sum and the product was given. Type 2, the difference and the product was given. Type 3 was x squared plus bx. Sorry, it was x squared minus bx equals c. And type 4, which is coming right now, is what happens if this minus changed to a plus. And now I have a specific question for you. How can you, something's going to have to change, maybe, you know, we'll talk about it. What would you have to change to answer this question? X squared plus 10x equals 56. So the only difference, seemingly, is, oh, sorry. These are the 3 types we've done so far: x plus y and xy, x minus y and xy. We just did x squared minus bx equals c. But now we're into the 4th type. And there are only 5 types for today. The 4th type is a question like this. That's only different from the question we just did, in that this question had a minus and this one has a plus. How much of the process needs to be changed to answer this question? I have here, this is page 4 of the, this is page 4 of this. So I want you to, in your groups, talk to your neighbors, and if you figured it out, you could type the answer into this box.
Professor,
Do you
does
know
this have something to do with what we discussed in the breakout room?
Well, that's what I want you to talk about. That's what I want you to try to get to the bottom of.
Okay.
I don't want to give too much of a hint. By the way, this Desmos activity, if you're doing it on a device or even, see this box here? If you click here, it allows you to upload an image. So like if you like wrote it by hand and took a picture of it, you could get it, you could upload it to me instead of typing into the box. Just wanted to mention that. But we are now all looking at page 4, which is asking how much difference would we have to do if there was a plus between the x squared and the 10x. I think I'd like to give you, we're pretty good on time because I'll give you 8 minutes to talk about that. Okay, I'm going to put you back into the groups for 8 minutes. Let me get my groups going, breakout rooms. 8 minutes to discuss what changes if the x squared plus 10x instead.
So you hear me do it, right?
Yeah, we're back in the main session. I guess we're gonna go.
Let's see what. Let's see what.
Hey, everybody, welcome back. So this is the fourth type. There are 5 types today, although the math majors, well, you have, I think 9 types. So so math teachers, be happy that just have 5 types. Here we are. This is, people got to this part, and a bunch of groups came here and said, well, since there's a plus here, they thought that this probably is just that the big difference in the question would be x plus y equals 10. But then when they did the question, maybe it didn't work out so well, because it's not x plus y equals 10. Someone from group number 1 want to unmute and explain what you guys came up with?
Who was group number 1?
Yeah.
Oh,
So we thought we should just switch around the x and the y, and we'll just call the one that used to be yx and the one that used to be xy.
but don't do it that way. Do it the way we talked about afterwards.
Oh, okay. So we're not going to rename it, but we'll go with whichever is bigger.
Yeah, we're going to say y is bigger, so y minus x equals 10. So we're going to start with that. This is our equation.
There you go. So that's what happened. It is still, and these questions, regardless of whether there is a plus here or a minus there, that's always going to be minus. Always. When the question starts off as x squared plus something x equals something, or x squared minus something x equals something, either way it becomes minus. Surprising. Because what happens is that this now the x is 10 smaller than the y. Before, the x was 10 bigger than the y. Now it's 10 smaller. So that's kind of surprising. A lot of people might expect this to be a plus, but the difference, these two things don't add up to anything special. They differ by that number. So whether or not, this is good to know, but you would want to write y minus x now, because the x plus 10 is bigger than the x. So the 5-step process is 5, square it, add it to the 56. So those groups that subtracted and got negative 33 and something seemed to go wrong, that's because there's nothing special that they should add to. They're different by 10, whether or not this is a plus or a minus. Take the square root. 9 plus 5 is 14. 9 minus 5 is 4. But this time, the bigger one is the y, the x plus 10. And the x, which is all there really was in the question, is this. So the only difference between these two questions is that in this one, we end up taking the bigger number, where we add the two things together, and we don't even need to do this other one if we don't want to. Whereas in this one, it was the smaller number, x was smaller than y, so we didn't actually even need to do this thing. But if we could do it, just be aware of those two numbers, one of them is the x and the other one isn't. It's y. Y wasn't even part of this equation, so choose wisely. Now, on a test, it wouldn't be like so many points off to accidentally pick the wrong one, but that is kind of confusing. But it is nice to know that regardless of whether, so type 4 is going to, so this one turned into xy equals and x minus y equals, whereas this type 4 turned into xy equals and y minus x equals. But it was the same process, the same 6-step process. They both were the kind that had a minus here. So they both had where you added after you squared, you added to the product instead of subtracting.
Professor, is it okay to just put both solutions as long as you correctly identify both?
Well, on delta math, they might just ask what's x, because
Gotcha.
y isn't even a thing. right? Y is just the convenient thing that we're calling x plus 10 at the moment.
Right.
So if it just asked for x, only one thing, writing both wouldn't be like so bad. But for full credit on the final, let's say, there'd be no mention of y. It would only want to solve for x. So you have to sort of stop at the end and think, I got it. I got these two answers. Which one is the answer? Well, I like to go back to here. I don't like to think about x and y. I think about one of these things is x and the other one is x plus 10. Well, the smaller one's got to be x because x plus 10's got to be bigger than x. So I think when you get down to these two things, if you're thinking, well, one of them is x and one of them is y, now I'm like confused. But if you think one of them is x and one of them is x plus 10, of course the x plus 10 would be the bigger one, the 14, and the smaller one would just be x.
Gotcha. Thank you.
Okay, and now, it's funny. This class ends, as far as I know, at 12:15. Which is am I right about that, or is it 12? Right,
Yeah,
it's not
Yeah.
12:30. Okay, so good news is that we have 30 minutes left, and this last question will take 30 minutes or less. So no chance that we have to
Let
watch.
me ask you, since students' instinct sometimes is to do that factor with the x plus 10 equals 56, would you ever teach students to solve quadratics by turning it into a system of equations?
That's an excellent question. And my answer is, when you get, so let's say what was it, x squared plus 10x equals 56. This is more like a sort of teaching philosophy more than history of math, but I want to say it because we have math teachers in here. So here we are. Now, would it be so bad if you said, I need two numbers whose product is 56, but one of them is 10 more than the other. So it has to be 4 times 14. It might be hard to do that with like 56 as the number, because is that not what you end up doing when you do this anyway? What is factoring besides saying, okay, I need two numbers whose product is 56, but because this is a minus, whose difference is 4. So when you're doing this is like a hard factoring, but it's plus 4, it's plus 14 minus 4. It's not an easy factoring because not everyone looks at 56 and says, oh, that's 14 times 4. So you could actually do this as the first step, and it wouldn't be that bad if it's something that factors. But if it doesn't, if you need quadratic formula, it wouldn't be a good way of starting that question. So no, I probably wouldn't mention this at all, except to say it's not totally illegal, but it would be really hard to continue that way because now you're looking for two numbers. Not one of them is not 0. It's two numbers whose product is 56, and one of them is 10 more than the other. So they'd have to really think about it. 2 times 12 is too low. 3 times 13 is too low. 4 times 14 works. Okay, we saved. This last one's a little bit hard. The fifth type. The fifth type is hard because it's the type where there is a coefficient in front of the x squared. Doesn't matter whether there's a plus or minus there. And that's what I'm going to show you now, the fifth type. I'm going to use a specific question. Let me find it. Okay, here it comes. The specific question that I'm going to use as my instructive example is 5x squared So this is the fifth type. I know I could split it up into two types, one where there's a plus here and one where there's a minus there, but I'm not going to. I'm going to treat this. I'm just going to say there's a fifth type. But there could be one with a minus, and I'll have you guys talk about what you would do if there was a minus there. But the key thing here is not really about whether that's a plus or a minus. Now, if you taught algebra, you know that this is particularly annoying when there's a 5 out there. You could use quadratic formula, you know, nowadays. But if you try to even this 5x squared plus 6x minus 63 equals 0, you know, maybe 5x and x, 5's prime, but it's hard to find these numbers. The good news is the Babylonians have a sneaky way around this. So let me get rid of this. You know how annoying it is? Let's just say it's when a does not equal 1. If you've taught this in Algebra 1, you know that it's quite annoying, and you might even just say, just use the quadratic formula. At least, you know, if it's going to work. But the Babylonians didn't do it with the quadratic formula. Oh, and they did these questions, though. And they would say 5 times the area plus 6 times the square side is equal to 63. What was the side of the square? So that they like this question. Here it comes. The first step is like shocking. The first step, I'm going to write down nice and easy. Step 1. Multiply both sides by, I'll just write a, which in this case is 5. So this number, whatever number is in front of the x squared, your first step is to multiply all the terms. And you might say, that's crazy. If I had trouble with a 5 there, how could making it bigger?
Because now all things are factorable by 5.
That would get me back to the first equation, though. You know, if I divided everything through by 5. But you're right, everything will definitely be divisible by that. But where does that get me?
Is it because the lead term is a perfect square? There's some advantage to that?
Yes. This number will definitely be a perfect square when you do this. Of course, we multiplied by it. We multiplied by 5. So 25 is a perfect square, and that's advantageous. But how could it possibly be? It doesn't. Why is that so good? Here it comes. I'm going to write 25x squared as 5x in parentheses squared. And I'm going to write 30x as 6 times 5x. And I'm going to leave the 315 alone, still 315. So what I want to show you is that this new thing will always resemble the original thing in that the 6 will be in both, that number will be the same. Whatever's before the x in the original equation will be the thing that's before the parentheses ax in the new equation. Now this is looking very, very hard, but check it out. I'm going to introduce a new variable. I'm going to call it u. Well, I'll say this, call 5x u. this turns into u squared plus 6. That 5x is in both places. That is looking a lot like type 4. U times u plus 6 equals 315. And since we're dealing with u, I'm going to call this u plus 6 v, just to not mix my x's and y's. I could call it y if I want. I'm going to call that v, so that it's, and now I have uv equals 315 and v minus u equals 6. Since v is bigger than u, because there was a plus here, I ended up with a v that was bigger. You're going to get to practice this with your neighbors in a second, but now I've turned it into the type that we already know. I really need some room. I'm going to erase, sorry for not managing my board space properly. So the 6-step process. 6 divided by 2 is 3. 3 squared is 9. 9 plus 315 plus, because there's a minus here, is 324. Square root of 324 is 18. 18 plus 3 is 21. Well, that's v, the bigger one. We don't care about v. We care about u. 18 minus 3 equals 15, which is u.
But don't you have to divide by 5?
That's right, because u was 5x. And the final step is to divide. So x is 15 divided by 5, which equals 3. So this, they basically turned the equation with the 5 in front. Oops, didn't mean to do that. They turned the equation with the 5 in front of the x squared into an equation that did not have a 5 in front, but it had the variable u. And then we solved that variable, but u was really 5x, so we had to divide at the end by 5. Pretty nasty. I'm going to make up another one of these for you right now. Actually, someone dig up, you'll have one less homework question. If someone digs up the homework, the PDF, if you could find one that has a ax squared plus bx, we'll do that one as a classwork question. So someone grab one just to make sure the numbers work out. If you go into the Google Classroom, this will reduce the homework by one question and give you a chance to practice it.
Question: will our homework be on Google Classroom or the
Oh, it's on
Delta
Google
Math?
Classroom. Yes,
Alright.
Blackboard is obsolete for now.
No,
Because
I mean Delta Math. Are we going to use that or
there's
Google?
also a Delta. There's also a Delta Math, but
Okay.
the most important.
And this homework is due when?
Well, I was going to have it due tomorrow, but I'm thinking that I'd like to make it due 2 days from now, just to give you a little bit of time, because this is one of the longer homeworks, but definitely make a dent in it. Make a dent in it tonight.
Where did you send the invite to Google Classroom?
Oh, so I have email addresses for everybody, sometimes more than one email address, but I am going to put up right now the Google Classroom code. If you didn't get an invite for it, then by logging in, hold on, let me get the classwork. Where is the, here we go, I go like this. So that's the code, UPA 7XAL. I'll put that in here. I really wanted to use Blackboard. I spent many hours trying to get Blackboard working, knowing that for sure everybody had Blackboard as a thing, as a City College student had access to Blackboard.
And what if we already submitted work to that?
You can submit, yeah, you can on the Google Classroom, you can attach your work to your homework now.
All right, but if we already submitted it to Blackboard is what I'm saying.
Oh, you don't have, I mean, if you can resubmit, that will save me some time because I have to, there's these 25 students, so I'll have to do both. It would be easier for me if you put it there, but you will get credit even if you don't switch it. But,
Gotcha.
So yeah, Google Classroom, and I had to lie, which is something I don't do. Google Classroom said, "Are you using this for a school?" I had to say no, because the school doesn't pay for Google Classroom. I felt a little guilty about that, but I don't think they'll care that much.
Little white lie.
Yeah, it's a small. I just so did anyone dig up one from the 324? Hold on, let me go back to here. The 324 was 315. The 324 was
Plus 9.
oh the 324 was I'm sorry, I got myself confused. 315 plus 9. We had to add. We had to add not because of this plus, but because of this minus. Okay, I'll tell you what I'm going to do. I'm going to send you to the groups for the final question of the day. I was going to do. Oh, I had a question there. Rats. But for time purposes, I'm going to just go all the way. Here is a question for you that I want you to talk to your neighbors about. I'll write it down over here also. It's similar to what we just did. Oh, that's already a perfect square. Please ignore the fact that that's already a perfect square, the 9. Do the process, turn it into a bigger perfect square. Okay, I want you to spend 10 minutes now, last question of the day, with your neighbors discussing question number, whatever number this is. There's a minus here, but that doesn't really affect the question very much. So I'm not calling it a different type. I'm not calling this type 6. I'm still calling it type 5. Okay, into your groups for 10 minutes, and then we'll finish out. We'll go over it and be done for today. So here you go, breakout rooms. And again, yes, there's a 9 and it's a perfect square already, but don't you multiply everything through by 9 first. Here you go. Okay, everybody. Is everyone back? Welcome back. So I really liked what I saw this, and I was mentioning this to one of the groups. You should know each day we start with like a new thing that starts off, kind of, I build up from something like easier, like we did today, and then it progresses to something, real difficult. But I don't want you to think, like if you look all the way back, look at all these pages for today, we started, with this, that's how we started. And I built us all the way up to this type. But I don't want you to think like tomorrow we start with this hard type and keep going. That's it for Babylonian quadratics, unless you are one of the 10 math majors, because the math majors have more types to study, and they're actually a lot harder. So, but they're math majors, so that's what they live for. But for the math teachers, this is the hardest question of the day, and this is about as hard as, in my mind. I mean, you might disagree. Maybe maybe I don't know sometimes, and I think something's easy that's actually hard. But this is about as hard as the stuff gets. It's hard. There's a lot of steps here. Each day we'll probably build up from something simple to something about this level. But you can see here, by the way, you are permitted, I permit you to skip that step. If you want to just jump from here to here, that's okay. That's what's always going to end up happening. Just be sure you multiply the 301 times 9 also. So you don't need to put what I just highlighted in green. You could skip that. If you want to not write this, well, let's not get too carried away. We should write all. This is about the minimal solution, this much writing. Now I'm going to actually stick around until 12:30. So I'm going to make this homework. I have to change the deadline on the Delta math, but this process is fairly tedious. So I think I want to give you 2 days, but please don't do it in 1 day starting tomorrow. I'm giving you 2 days so you can chip away at it today and tomorrow. Not so, if you're going to do it in 1 day, you should just do it today then. So don't do it all in 1 day, because there's going to be another homework coming tomorrow's lesson. What are we learning tomorrow? Oh yeah. Yeah, it's tomorrow's same difficulty as today. This is the difficulty of the course. I know some people said, it is fast, but we are trying to do a semester's worth of history of math in 16 classes. I do have to make up yesterday's class. I don't know how. It might just be a video that I make that you watch on a Friday or a Saturday or Sunday, but I'm not cutting a topic out just because I couldn't be here yesterday. So we'll figure that out some other time. For now, lesson 4 is coming tomorrow. So I hope you like that. I'm glad to get to see everyone in person. Sorry for the rough start, but I'm not going to leave here until 12:30. I'm doing office hours every day after the class ends, and I'll stay for at least 15 minutes, if not 30. So feel free to stick around, and feel free to leave right now if you're all done.
Thank you, Professor. I did have a quick question, I guess,
Yes.
in regards to the second homework, the Plimpton 322, I believe it is, tablet.
No, that shouldn't. Wait a sec. That was on homework 2. What was it? Was it just translating?
Yes, it was translating.
There was no math to do.
No math.
Okay.
No math. I guess my question was, I wasn't sure where the cuneiform began and where it ended because of all the lines.
Yeah.
Could you help me just kind of identify the beginning and the end of the?
Yeah. Let me bring. Someone asked about supplemental homework. Yes. You don't do the math teacher. No, the math teachers. Yeah, they leave the supplemental homework blank. That's right. So let me take a look. I have here in the Google Classroom. Do you use Blackboard for a lot of classes?
Yes, sir.
I'm just really troubled by it.
Most, if not all, the classes. I think this is my first class where we're using Google Classroom.
I guess people figured it out, right? I mean, the teachers must know some ways of making it look like I was really struggling, but it could be. So let's take a look. Class, where is it? Class 3, class 2. I see. I had you. Which one is that? Is that this? Babylonian arithmetic?
Yes, sir.
This is also one that wouldn't be on the final, you know. It was just more like tomorrow we're going to analyze Plimpton 322, like what the actual numbers are. So it is, where is that?
Previous page.
Oh,
There you go.
so what are they asking here?
So like just looking at the first row, you see the I guess the triangle with the line.
Yes. So that's a
Right.
big one. That's a very large one. So this is like 01. And I realize now, I probably should have told you that in their 60th places, they do this where they make the ones really large. So you see this thing over here, like you could clearly see a 59, right? In the back, like there's 9, and then here's 5 that are diagonal. So did you see the cursor, by the way?
I do.
Okay, so that's 59. And this thing is what giant 1. So it's 0159. In other words, 119.
Nice.
But I probably didn't explain that too well. What is this? Did it ask you to actually do anything on this? What did it say? Oh, here's a section. What are the numbers on it? I see.
In base 60 and then base 10. Yep.
Yes, yes. So this is 10159, and this one is 249, which is 169.
Right.
So that's how to read that. It is not easy to see, especially these weird looking ones. They're really kind of large.
Yeah.
So
I thought you would. It looks like a dividing line between columns. So
Yeah.
I could assume that on the third row, second column, that's a 1, right? With the 5.
This is a now I got myself confused. So here we have 39.
Right. 49.
49. And here we have in the second place, because it's diagonal already. So this is 50. And this one is in the third place. This is 01, 50, 49. So it's a gigantic number. Because you see the diagonal ones are representing like the tens, like the tens place of the second digit. So because these are diagonal, this is its own place. This is 50.
And about the second row, the first one on the first column, the second row.
Second row of the first one?
Column. First column. No, first column.
First column, second row.
Yeah.
So for that one, we have just a regular this is 7.
Yeah.
And this is a 6 with a 50. So 56. 07.
And what is the symbol on the top?
Yeah, that confused me as well. The symbol on the top left of the second row.
On the second row of the first column.
Yeah,
Yes.
you see it's like a triangle with a line.
Oh, I don't know exactly what that is. I better look at my. I need to bring up the original. Hold on, because I took that from Plimpton 322. We definitely don't want the photo because that one's really hard.
It is not a problem to find them, but it should be clear because it's a little confused. Yes.
Maybe this one. Can we see it?
It is not clear too.
It's pretty hard. It was just, those questions were more for fun. It's not that you actually, like, I would never ask on a test. I just wanted to introduce that to you just so that, like, if on your own you started Googling, Babylonian math, and then they showed this cuneiform, I'd want you to at least be familiar with it a little bit. Actually, when you see the whole Plimpton 322, you can see they have like the column numbers or the row numbers 1, 2, 3, 4. We're going to learn more about that tomorrow. That we're actually going to analyze Plimpton 322, like not just what the number. We're going to not. It's already going to be turned into base 10 numbers. Actually, we're done with base 60. Even today, we didn't do any base 60.
Okay.
They did their algorithms, of course, in base 60, but once we learned the base 60, we just started analyzing their algorithms with base 10 numbers.
One question for homework. We'll have homework on both the Google Classroom and Delta Math, right?
Yeah, well, the Delta Math is just 4 questions. So, but most of it's the Google Classroom.
Okay, no, I just want to make sure so I could check both.
Yes, always check both. The thing about Delta Math is that it forces you to keep doing one until you get it right. So it's self-checking, whereas the Google Classroom isn't. So that's why I like that.
Okay. All right. Thank you for your time, Professor. See you tomorrow.
Thank you, Professor.
You're welcome.
I have a question.
Yes.
I just share my screen. I'm trying to so the homework you're talking about is due Thursday. Is one that, let me just read it. Is the one that says also posted on Google on Delta Math assignment, use the Babylonian quadratic process to solve 1 to 4, and then you ask for the approach for 1 to 4, use the approach where you factor out the x first. That's
Oh.
yeah, that one right there. That's due. That's the one you're talking about. That's due Thursday.
Yeah, basically, like here is here's type 1.
Mm-hmm.
Ooh. Oh, I see. Here's type 2 and here's type 3 and 4.
Mm-hmm.
And here's all these are type 5. That's right.
Okay, so you're asking to do that. All right, so I'll get working on it now then.
Yeah, now you see weird fractions involved here. That's because these are actual questions that they did with fractions in them. So I want you to apply them. But the Delta Math will have regular numbers for questions like 1, 2, 3, and 4 here. The Delta Math will be nice.
Oh, is that up yet? Because I don't see it.
Oh, the Delta Math? Okay.
For quadratics, I think. Yeah.
Okay, let me take a look. Because that, I do want that. I thought it was up. Let's take a look. Okay, let me see. Maybe I assigned it to the wrong class. So thanks for letting me know. Let's take a look. Delta Math. Edit assignment. Let me see. I have to change the due date also. So assignment 3, Babylonian Quadratics. Let's see. Summer history of math. Oh, 7. This is today. So you're saying it's not posted?
Because what I see right now from my end is this. I'll read it to you.
Oh, here, let me just change the due date also.
So on my side for Delta Math, I have assignment 2, base 60.
Yeah.
I have making sure you can log in and do your assignments.
Yes.
And then I have assignment 1, bases other than 10. That's the only thing that pops up on my side.
I see. Can you do like a refresh just to, and I'm also gonna come over here and change this to immediately. And see, it's assigned to summer 2022.
Okay, so now I see the assignment 3. The due dates did not change though for the other ones.
I see. Okay, so let me do this. Select periods, summer 2022. Okay, let's see if this fixes it. Okay, now refresh and see if it shows it.
Nope, the due dates is still the same, but I do see assignment 3.
Okay, let me look now at the due date. 7/14. Maybe it takes a little
Takes
bit,
time.
maybe, but at least you see the assignment there. Email me later tonight if it still isn't, if it's still doing that.
Okay. Yeah, because I'm still working on assignment to the changing of the base, but the other stuff is done.
Okay, great.
Mhm.
Hi, Professor, a question. Can
Yes.
you open the supplementing?
Math major?
Mhm.
Okay, so for the math majors, supplemental. So this one has 1, 2, 3, 4, 5, 6, 7 more questions for you to do.
Okay, because I saw it's due tomorrow. It's for
I'm gonna
today
check.
or
Okay, yeah, let me change the due date. Google Classroom, unlike Delta Math, where it doesn't even let you, Google Classroom allows late submission. So, it doesn't matter if as long as I know not to penalize for it, it wouldn't matter, but it's good just to not confuse people. I'm going to do the same thing for class 3, the other assignment. Okay,
yes, thank you so much.
you're welcome. Okay.
Bye,
Okay,
have a good day.
thanks. Okay, anyone else? Like I said, I'm here. I'll stick around if people have questions.
I had a question about what we did today. I had to step away for a few minutes, so I'm not sure. Like, sorry if it's something that you already went over. But were these examples like chosen specifically to only have one positive solution, like the quadratic ones?
So questions like these will always have one positive solution and one negative solution. But
Yeah,
the
the
Babylonians,
negative one was like the throwaway solution at the end.
right? So only this will give us just one answer. So like any question that's like x squared, plus or minus, equals c. If you bring that c over, this minus means that, the factoring would always be a plus and a minus.
Yeah.
So there will only be one answer for these questions. There is a negative answer that we don't consider.
Yeah.
And if you now when we were doing these questions, we got like x equals and x minus whatever equals.
Yeah.
Does that other answer, would it work?
At the end of the algorithm, when those last two numbers, like in the first example, 10, 4, I think it was 10 was our positive solution. 4, -4 would be the solution. And that was kind of what I saw through all the examples.
Are you talking about this, not the ones with x, y, but a question like this? X squared plus 10x equals 56?
Yeah, but I mean, we change it into the same thing, right?
It turned into, hold on. I just want to, I don't want to say the wrong thing. So let me come over here and find one that's fully worked out. Not that one. This one. So the two answers were for x and y. X was 4 and y was 14. But notice 14 is not the answer to any question. It's not the other answer.
-14.
Oh, -14. I see. So that's kind of funny, right? Because the y is x plus 10. If the y is 14, yeah, I guess it does give us the other answer, but I also wouldn't have been that surprised if it didn't. It's kind of like, but you're right. The other answer, the y answer that we ignore, if we made it negative, it would turn into the other x answer.
Yeah.
Right. But we won't.
It doesn't.
But you're right that that we could, but they wouldn't, because they were talking about a square that has a certain area and you're adding it, so they wouldn't have negatives in
They
it.
would always have a positive number on the other side of the equal sign when they were doing these things.
Oh, yeah.
Okay. Yeah, that makes sense then. All right, thank you. Have a good one.
Okay, you're welcome. Okay. Hello?
Professor, I had a quick question about delta math.
Yes.
I know I emailed you. What should I do? Because for some reason I still can't, like, even though I know I'm getting the right answer, delta math is still saying it's wrong. It was the base, I think it was like converting.
Oh, I see. You're and this is it's Antigone.
Yes.
So let me take a look just to see. Maybe I can see if something's going on from my end with that. I will get that straightened out, and I will make sure that you get credit for those, especially. Maybe you could submit the written work, your written solutions to your delta math along with the other one, and just say my delta, this is my delta math.
Okay.
But I'm curious. So you're talking about assignment number 1?
Yeah, the base is other than 10. It was the convert from base 10 fraction to a decimal in another base.
Yeah. Let me take a look. I'm going to
But
take up your.
I think I emailed you my work that I worked out, and showing you that it was coming up with the same answer, but I don't know if it's just based on how I'm writing it in delta math. Like I did the little subscript and it's still not recognizing it.
Okay, well, so this one was okay. So let me just go through and find. I see 0.
Yeah, I did it like so many different times. The last, like, when I realized that, I redid the next problem with just the decimal point. But
did you, that leading 0, was that an issue? Let's see.
That one didn't work.
This one doesn't have a decimal in it. Let's just see. This one, you have the leading 0. Maybe if you take out because so far I haven't seen one.
Like this one right here. I started like realizing, let me not use the leading 0, but.
Did you put the little 5 there, or was there already?
Yeah, I put the 5 there. It's like there's a button where you can do the subscript. And so I was doing that. And I'm like, is it the spacing? Is it?
Did you try one without the subscripts? Where you don't type the subscript at all? I forgot how. I have a feeling.
No, I didn't.
I'm curious.
Like, see, like here, I did 0.2, the one beforehand. I did 0.235, trying to see if that would like do something.
I'm wondering if you just wrote 0.23 and didn't.
0.23.
Yeah, and didn't put. Try to just assumed it knew what subscript should be there.
Yeah, you don't need to use the subscript. Just put the number and it's gonna.
Okay. So I'll try it with the new one.
I made that module, and I should have made it so that the subscript was already in there, and they took away my access to make my own module, so I can't fix it, unfortunately. Thanks. So that's the mystery. Don't put the subscripts in.
Yeah,
now,
so I'll work on that one, and then.
That's fine. I'll you know what I'm going to do? I believe from my end, I can just go like that, and now it's fixed. Okay, so now you have 100.
Okay, great. Thank you.
It's all done.
All
You don't
right.
have to do
Thank you
anything.
so much.
Okay, you're welcome.
See you.
Hello?
Yes, I had just one quick question, Professor.
Yes.
So when you mean by like you said that the half of the students are math teachers and half aren't. So do you mean that like math education or math graduates and math teachers?
Right. There's math education. Those are the math teachers. I think of them as the math teachers. And then there's like math majors, who are taking like extreme advanced math courses.
Okay, I understand. Because I'm a math education major, so that's what I was trying to make sure.
Okay, so so you do not need to do supplemental.
Okay, cool. Thank you.
Okay, you're welcome. See ya.
See ya.
And that's the end of class 1. I'm stopping the recording now.